All right, Math 100 students, let's get started with our lesson on exponents. So the first thing I want you to do is go ahead and put 4.1 in that box. In this section, we will discuss the rules of exponents. Exponents are used to indicate repeated multiplication by the same number, called the base. So let's go ahead and get started right away. So first, let's talk about this number 5 squared here. First thing I want you to do is draw a line to the 5. That is our base. And the 2 is considered to be our exponent. So hopefully you have printed out these notes already. The notes are saved to Blackboard. So the best thing to do is to print out the notes and write along with me. Now, what does it mean for us to compute 5 squared? Well, 5 squared equals 5 times 5. So that basically just means repeated multiplication, which equals 25. All right. Similarly, negative 7 cubed, another way to write negative 7 cubed, or another way to indicate multiplication is by parentheses right next to each other. So negative 7 times negative 7 times negative 7. And of course, you can use your calculator to figure out what negative 7 times negative 7 times negative 7 is. So go ahead and do that. Pause the video, see what you get. So you should get negative 343 as your solution to that. What does x cubed mean? X cubed, well, it just means x times x times x, right? So x cubed is just x times x times x. Next, we have negative y to the 4th. Now, that's a little different, right? What I want you to first consider is that that negative sign is not in a parenthesis. So it is not to the 4th power. This is negative y to the 4th is considered to be negative 1 times y times y times y times y. So I want you to pay close attention to the fact that this negative is not inside a parenthesis. Therefore, you will not multiply negative 1 times itself 4 times. If the negative 1 was in a parenthesis, yes, you would multiply negative 1 times itself, times itself, times itself, which would end up being a positive number. All right, let's continue. We're making progress. Next, we're going to go to write an expression without exponents first and then simplify. So here we have x to the 4th, which means x times x times x times x. So all of this is x to the 4th power. Then we have times x to the 1st power. So this is x to the 1st power. So if you multiply x times x times x times x times another x, what do you get? You get x to the 5th power. Now the shortcut would be to simply do what with the exponents? What would be a shortcut? Because no one wants to multiply or write out x over and over again. You want to just consider the shortcut, which is to add the exponents. So the product rule for exponents a to the m times a to the n. Let me also point out here that you have to have the same base here. Same base. When you have the same base, the rule is when you're multiplying using the same base, you can add the exponents. So a to the m times a to the n equals a to the m plus n. Because notice again, up here, we added 4 plus 1 to get the x to the 5th power. So this is a rule you need to learn because it will make computing the math much simpler if you understand the rules. Next, we're going to try out some practice problems. We have x to the 3rd times x to the 8th. So again, we have multiplication. Do we have the same base? Yes. And what I mean about base, I mean something that is being raised to a power. So this x is being raised to the 3rd power. This x is being raised to the 8th power. The x's are the same. So we have the same base. Therefore, we can add the exponents. X to the 3 plus 8, which equals x to the 11th power. Similarly, when you go over here to 2 to the 2nd times 2 to the 3rd, we have the same base because 2 is being raised to the 2nd and to the 3rd. So what we can do here is you could write down 2 and add the exponents to get to your answer. Of course, you could do this in another way, right? So we have 2 to the 5th, which equals 32. But you could have also, for this problem, since we're strictly dealing with numbers and not variables, you could have simplified 2 squared first and multiplied it times what 2 to the 3rd power equals to, right? So you could have multiplied 4 times 8, right, to get to 32. Next, we have y to the 4th times y to the 3rd times y to the 1. So, very important to point out, we have the same base. So we can add the exponents. The exponents are 4, 3, and the 1 is understood for the last exponent. So that's important that you know the 1 is understood. Even though you don't see it. So it's not customary that you write an exponent of 1. So normally you will not write it. It's understood to be a 1. I'm just writing it here for clarification. So now we have y to the 4 plus 3 plus 1, which is y to the what power? 8th power is correct. Next, notice that we have parentheses right next to each other. This parenthesis right here, they are right next to each other, which indicates multiplication again. So what can you multiply? Well, you can multiply the -3 and the 5, of course. You can multiply the x squared and the x together because we have rules for it now. And we can also multiply the y to the 7th times the y to the 6th. Right? So let me write it out and write them next to each other. So -3 times 5 we can multiply together. X squared times x. Again, what is that rule? Then also y to the 7th times y to the 6th. So let's multiply -3 times 5. That's -15. X squared times x. That is x to the 3rd power. And y to the 7th times y to the 6th. What is that answer? Y to the 13th is correct. Now, let's proceed to the next rule. First, write an exponential expression without exponents first and then simplify. So the point of me going through this first before we go to the rule is so that you can see why the rule exists. So for example, negative 2s all to the fourth power. Notice that that negative is on the inside of that parenthesis. Therefore, that negative 1 is considered to be to the fourth power. All right. So all of this inside the parenthesis is to the fourth power. Therefore, we will rewrite it as negative 2s times negative 2s times negative 2s times another negative 2s. So again, this is repeated multiplication. Let's multiply negative 2 times negative 2, which is 4, right? Times negative 2, negative 8, times another negative 2, which is 16. Then we have s times s times s times s, which is s to the fourth power. Moving on, we have x to the third squared, which means if we wrote it as repeated multiplication, it would be x to the third times another x to the third, right? Which is x times x times x times another x times x times x. So what is that? What is x times x times x times another x times x times x? It's x to the sixth power. Now notice from these two examples, there was a shortcut, right? Notice we could have just multiplied negative 2 to the fourth power, and then we could have taken negative 2 to the fourth power, and we could have taken s to the fourth power, which would have given us the 16s to the fourth power. Similarly, if we could have taken a shortcut for x to the third quantity squared by doing what to the exponents? So what do you think the operation is? Multiplication. So that's the power rule for exponents. A to the m to the nth power would be a to the m times n. So this is the shortcut, which is also a to the mn. So when you don't have a dot between the two variables and the letters are right next to each other, that's also considered to be multiplication. Just like this negative 2s were right next to each other, that negative 2 is being multiplied times s. All right, since we now know the shortcut, let's go through this pretty fast. We have z to the third to the fifth power. That would be what? Z to the 15th power. Then we have y to the negative third to the negative fourth power. That would be y to the 12th power, because a negative 3 times a negative 4 is positive 12. Moving on, we have x squared, y cubed, all to the fourth power. So here we're going to multiply the 4 times the 2, and we're going to multiply the 4 times the 3. So that's x to the 8th power, y to the 12th power. Notice here, since x and y are not the same base, we do not multiply. Use the multiplication rule here, where we add the exponents, because we do not have the same base. Next, we have 4x to the third, y to the z, all to the third power. So that's 4 to the third, x to the what power? 9th. And what about the y and the z? Again, what is considered to be the exponent for y and for z? Well, 1, right? So you're really just multiplying that 1 times 3. So we have y to the third, z to the third. Let's clean this up a little bit because we can do a little bit more work, because we know that we can put 4 to the third either in the calculator, or if we just know 4 times 4 times 4 is 64, we can go ahead and write that down. 64 x to the 9th y cubed z to the third. Next, we have 2 to the third to the 7th power. Okay, again, we can use our power rule for exponents. 2 to the 21 power. Because we have a number here, 2 to the 21st power, you could put this in the calculator. Now, of course, you don't want to put in the calculator 2 times itself 21 times, right? So you need to find the shortcut rule, the shortcut key on your calculator, which is probably like, you probably have to either punch in 2 y to the x 21, or to find that little caret symbol like so, 21, to see what does that equal. So I'm gonna give you a couple seconds to get to your calculator so that you can figure out what is 2 to the 21 power. All right, so 2, we have 0, 9, 7, 1, 5, 2. So 2,097,152. All right, next we're going to move on to the last example for this section. We have z to the 2nd power and that to the 4th power, which is z to the 8th, right? Times we have z cubed to the 3rd power, which is z to the 9th, correct? And now we don't stop here. Can you tell me why we must keep going, right? That's your hint. Why we must keep going. Because we have the same base, therefore we must combine those two. So we get z to the what power? 17th power, since 8 plus 9 is 17. Let's move on to the next rule. First, let's look at this example, a, b, c, all of that squared, which if you wrote it all out would mean a, b, c times another a, b, c, correct? Because we're squaring it. Now, of course, if you wanted to group the same bases together, you could rewrite it if you wanted to as a times a, b times b, right? Times c, which is a squared, b squared, c squared. Now, of course, we don't really have time to do all of that, right? So what you can do is use that rule, right? As you can see, all of the exponents on the inside are the same, right? The exponent is understood to be 1. So all you're doing is multiplying 1 times the exponent on the outside. So the next rule is the product to a power rule for exponents. So xy to the nth would be x to the nth power times y to the nth power. So again, this is multiplication on the inside of here. But what you're doing is simply taking the nth power of everything, every exponent on the inside of that parenthesis. So let's proceed with some examples. We have a, b to the 4th power. Therefore, it would be a to the 4th power times b to the 4th power. Simple as that. Then we have 3 to the 3rd power here times c to the 3rd power. Now, since this is a plain number, not a variable, we must continue to simplify it. 3 cubed is 27, and of course we just rewrite the c to the 3rd power. Next, we have this example, and I purposely made sure that I put the negative on the outside. So, question, is this negative being squared? Is it squared? Because this is very important for you to understand. If it's squared, then my answer would be a positive answer. If it's not squared, my answer would end up being a negative answer. And knowing the differences between those type of situations is vital to ensure that you do well in the course. So in this instance, the negative is not on the inside of the parentheses. Okay? Now, so we really have a negative 1, if you wanted to separate it, times 2 to the second times x to the 6. Where did 6 come from? 3 times 2. All right. Next, we have y to the what power? Squared. Squared, because you have y to the first power. 1 times 2 is 2. So final answer, we have a negative 1 times 4, negative 4, x to the 6, y to the second power. Let's proceed with our next rule. So it says write the exponential expression without exponents again. So we have 3/5 squared. Of course, that just means 3/5 times another 3/5. Or if you wanted to write 3 times 3 over 5 times 5, you could write it like that as well, which is 9 over 25. Now we could have just simply done what? If you look at it, if the answer is 9 over 25, we simply could have just squared everything that was on the inside of that parenthesis, which brings us to the quotient to a power rule. So you have x to the nth power here over y to the nth power. All right. So here we have 2 to the third power over x to the third power. So 2 times 2 times 2 is 8. And of course, we just simply rewrite x to the third power down. Next, we have 3x squared over 2y to the third to the fifth power. So that's 3 to the fifth, x to the 10th. Where did the 10 come from? That's right, 2 times 5. Over what? What would you write next? Two to the fifth power, y to the 15th power. All right, so in your calculator, you figure out what 3 to the fifth power is and write it down. And you'll figure out what 2 to the fifth power is. Write it down. So your final answer, 243 x to the 10th over 32 y to the 15th. Next, we have 2 to the 4 x to the 12 over 3 to the 4 y to the 8. It's very important that you do not ignore the numbers inside of parentheses and that are raised to a power on the outside. Please do ignore the numbers. They are being raised to the power as well. That's probably one of the main issues I see students deal with. They ignore that the 2 should be to the 4th power. The 3, it should also be to the 4th power, for example. Next, let's clean this up a little bit. Go to your calculator. 2 to the 4. We have 16 x to the 12th over 81 y to the 8th. It's very important that you understand that you can always stop the video and work out the problems before I give you the answer. If that will help you gain confidence that you understand the concept. All right. Next, write an expression without exponents first and then simplify. So here we have again an example, x to the fifth over x to the third power. So x to the fifth is x times x times x times x times x divided by, and x to the third is x times x times x, right? So we can simplify that the old way, which is to simply cancel out common factors, right? X cancels out with that x cancels out with that x, leaving us with x times x, which is x squared. Now, what would you think would be the shortcut for this rule? To me, it would be simply doing what to the exponents? All right. If you said subtraction, you were right. So we have x to the m over x to the n will equal x to the m minus n. So that's the quotient rule for exponents. So here you have y to the 6th minus what? 1. Since the 1 is understood here, which is y to the 5th. Next, we have this example. Notice that you could clean this up just a tad, right? Because 8 and 6 have the factor of 2 in common. So 2 goes into 8 4 times, 2 goes into 6. 2 goes into 6 3 times, right? And then we have 4, right? We can add these exponents here since we have the same base, y to the 8th power over 3y cubed. Now, can you tell me, however, why we are not done with this problem? So you got to be able to catch this without someone telling you. So why are we done with this problem? Well, we have the same base showing up, so we have to combine these two using a rule. Since this is division, right? When we're dividing the same base, we subtract. So we would have to subtract, right? So y to the 8th minus 3, which is 4, y to the 5th over 3. So you can write it as 4/3 times y to the 5th or 4y to the 5th over 3. It's the same. Next, notice we have the same base in the numerator. So let's go ahead and combine this, since this is multiplication. And I like putting little dots between this, although the book does not put dots to indicate multiplication. They just write the variables and exponents right next to each other without using the dots. I like using that symbol, but as long as you understand that even without the dot, it's considered to be multiplication, you should be okay. So in the numerator, if you add 3 plus 5 plus 7, what do you get? You get 15. And then in the denominator, you have a 4 plus what? 1, which is 5. And since we're still dividing with the same base, we use subtraction. So we have a to the 15 minus 5, which is 10. Next, notice that the numerator is squared, but the denominator is not. So let's work on the numerator first. So that rule here, notice we're going to have to multiply the exponents. So that's a to the 6th, b to the 8th. Let's rewrite a, b to the 5th. Why aren't we done? Because we have the same base here and here, right? So we must combine it as 1a and 1b. All right. So what will be the final answer? A to the what power? Well, notice we have a 6 and we have an understood 1. So 6 minus 1, 5. Right? And then we have b. We have 8 and 5. 8 minus 5 is 3. Right? That's our final answer for that. Then I have 4 more problems that, will challenge you to think a little bit, that are a little outside of the box of what we've been talking about, but using the same rules. So x to the 1/2 squared. Now the rule is to do what with these exponents? Multiply them. So in this case, you would have to understand how to multiply 1/2 times 2, right? So 1/2 times 2. How do you multiply 1/2 times 2? Some people will say, put the 1 under the 2. Okay, that's fine. What else? You can multiply across. You can cross cancel. I like cross canceling. The 2's cancel out, leaving us with x to the 1st power. But again, 1 is understood. You don't write 1 as an exponent. And then here, the rule, we have multiplication. So you have the same base again, and you're multiplying. So what is the rule for the exponents? The rule is to add, right? The exponents. What are the exponents? P plus 1. And the other exponent is the other p. So are you able to add any of this? Of course, because you have like terms. So you have x to the 2p plus 1. That's your final answer. Next, we have x to the p plus 1 to the 2nd power. So again, you have exponents right next to each other, raised exponents. That means to multiply 2 times p plus 1. What is that? What is 2 times p plus 1? If we distribute that, we get 2p plus 2. And lastly, what is the rule for this example? We have division. So the rule is subtraction. So x to the 2p plus 1 minus what? P. So 2p minus p is 1p plus 1. So this concludes this lesson on exponents. I hope you gain a lot of information from it. But if not, you can always ask questions either through problem solving forum, or just ask me in class. If you're in my ground course, or if you're in my online course, you can always use the problem solving forum to ask me questions. Until the next time.